Let's learn how to solve exponential equations. On our agenda, we're going to solve the exponential equations when they have the same base and when they have different bases. Let's get ready. You're going to need your notebook, pencil, and I want you to try these without a calculator. So one way to solve exponential equations is to use the property that if two powers with the same base are equal, then their exponents must be equal. So if my base is both b and I have an equal sign, then x must equal y. You do have to know that b has to be greater than 0 and b can't be 1. Solving by equating the exponents. So here I have the same base of 2. If the bases are 2, 2 to the something equals 2 to the something, those somethings must be equal to each other. So we just write the exponents equal and solve. It is a solving, so you can always check your work. So you can plug back in the 4, and 12 minus 3 is 9, and that one works. Go ahead and try those. The answer to the first one is -2, and it's okay to have a negative variable. B is 6, and the last one is -8. What happens here? Well, you notice we have different bases now. So we want to try to rewrite them so they have the same base. You cannot just do 4 times 2 and magically turn it into an 8. You can't do 8 divided by 2 because then you're doing something different to the sides. But what you can do is rewrite them each with a base of 2. So when you're rewriting with a common base, you want to always make the base smaller. Don't think about going bigger. Think about going smaller. So 4 is in fact 2 squared. I have not changed the problem at all. I have not divided on one side. It's just replacing the 4 with something that's equivalent to it. And then 8, in terms of a base of 2, is 2 to the 3. And then we have x plus 1. I am going to put the x plus 1 in parentheses just to remind me that when I have the power raised to a power and I'm multiplying, I have to do the distributive property. So remember, power raised to a power is multiplying. So now we get 2 to the 6x equals 2 to the 3x plus 3. I distributed as I went. And we're back to where we started. We have the same base. I can set the exponents equal to each other. X equals 1. I'm going to check my work. So this is 3, and then this is 4 to the 3, and then this is 8 to the 2. They both equal 64, so it works. Go ahead and try these. I'm not going to do the whole thing, but I am going to show you that, again, this should be 2 squared and this should be 2 cubed. And then with the 16 and the 64, you could go all the way down to 2's. You could get away with just doing 4 squared and 4 to the 3rd. We're going to get real familiar with our powers of 2's and 4's. And then 25 and 125, I can make those have a base of 2. When you solve them, yeah, we're going to get fractions. That's okay. Get 11/4 on the first one, -26/5 on the second one, and 30 on the last one. And when you plug them back in to check, we're not going to get extraneous answers. You really are checking to see if you did the work correctly. Here we have a base that's a fraction. So remember, a fraction probably just came from a negative exponent. They are different bases, so I want to think about what base I'm going to write these with. I'm going to write them both with a base of 2. So 4 is 2 squared to the x. And 1/2 written with a base of 2 is 2 to the -1. Don't forget about those negative exponents. Usually we want to get rid of them. Here we're probably going to be using them more often. Parentheses, x minus 3. Now we have the same base, so I'm going to distribute and solve. I get another answer of 1. Go ahead and try those. I'll talk about the bases again. So 2 is 2, and 1/8 is 2 to the -3. And B, you could stay with the 4. I think I would stay with the 4, and then this would be 4 to the -2. And I have a base of 3, so I would make this 3 to the -3. Don't forget the negative. Don't just call it 3 to the 3. And then when you do your work, you get the first one to be -6, the second one is -10, and the last one is -3. So to recap, if the bases are equal, set the exponents equal. If the bases are not equal, rewrite them so they have the same base. If you have a fractional base, probably have to rewrite that with a negative exponent. And always think you want to make a smaller base, not a larger base. Nice job.